So let's see collisions. So now let's suppose for simplicity we have two bodies. The mass of first one is m1 and it's moving with speed u1. Mass of second one is m2, it's moving with speed u2 in same direction. They collide. What will happen? Now what happens is the speed of this first one will increase, speed of second one will decrease. And suppose velocities after collision are v1 and v2 in the same direction. Okay, so this is one dimensional collision. So what can we say about this collision? We can say the total momentum before the collision is equal to total momentum after the collision. This is just law of conservation of momentum. Okay, so we know this thing from the law of conservation of momentum. The total momentum before collision is equal to total momentum after the collision. So m1 u1 bar plus m2 u2 bar is equal to m1 v1 bar plus m2 v2 bar. Okay, after that there are some things that we need to remember in case of collision. One term is defined as one term is there which is known as coefficient of restitution. Okay, it's denoted by E generally, and it is defined as the relative velocity of separation divided by the relative velocity of approach. So what is relative velocity? Relative velocity is velocity of one body minus velocity of second body. Okay, relative velocity of separation. So now when they collide, two bodies are in contact with each other. With what velocity they are separating? So they are separating with velocity. So if this is second one, if this is first one, then we can say they are separating with the velocity of v2 minus v1. Okay, or if this is first, if you call this one first, this one second, then they are separating with velocity of v1 minus v2. Okay, then it is relative velocity of separation divided by relative velocity of approach. So it will be v1 minus v2 divided by what is relative velocity of approach. So which body is approaching? The second body is approaching close to the first body. With what velocity is it approaching? It is approaching with velocity of u2 minus u1. Okay, so it will be v1 minus v2 upon u2 minus u1. Okay, v1 minus v2 upon u2 minus u1, or vice versa. You can say if you change the numbering of bodies, it will be v2 minus v1 divided by u1 minus u2. Okay, so for 3D case we'll denote it by vectors, and for 1D case you just have to take v1 minus v2 upon u2 minus u1. So is this quantity clear? Okay. Then now there are some types of collisions. So what are those types? So there is a perfectly elastic collision, there is completely inelastic collision, and okay, that is perfectly inelastic collision. And in general, the collisions that happen in our day-to-day life, they are inelastic collisions, not perfectly inelastic. Okay, so let's see what is the difference. So there are three types of collisions. One is perfectly elastic collision, then there is perfectly inelastic collision, and you have inelastic collision. Okay, so what is perfectly elastic collision? So perfectly elastic collision is the one in which total kinetic energy is conserved. So kinetic energy before the collision is equal to kinetic energy after the collision. Okay, then okay, so this is perfectly elastic collision. Then what is perfectly inelastic collision? So kinetic energy is not conserved in case of perfectly inelastic collision. But one thing happens, the two bodies stick with each other. Okay, what happens? Two bodies stick with each other and move ahead. Okay, is this thing clear? Video lagging? So then you have, okay, kinetic energy is conserved in perfectly elastic collision. In perfectly inelastic collision, there is some loss of kinetic energy. And apart from that loss, what happens? The two bodies stick together and move. So bodies are not separating. So what will be velocity of separation? In this case, the bodies are not separating. Velocity of separation will be 0. And that's why what is coefficient of restitution? The coefficient of restitution will be 0. Okay. Then here, in case of perfectly elastic collision, the velocity of approach and velocity of separation, it will be equal. Okay. So E is equal to 1. And in most of the collisions, they are not perfectly elastic, they are not perfectly inelastic. So what happens is kinetic energy is not conserved and the coefficient of restitution, it is in between 0 and 1. Okay. Now one more thing, for all kinds of collisions, the momentum is conserved. Okay, so total momentum before the collision is equal to total momentum after the collision in all kinds of collisions. Okay, so these are the some factors which separate the elastic and inelastic collisions. After that, we discuss the perfectly elastic collision. So we discuss meaning what do we want to find out. So we know the initial masses and initial velocities of these bodies which are colliding, and we want to find out their final velocities. So if the collision is perfectly elastic, what will happen to the final velocities? That's what we want to find out. So we use the two things. One thing is total momentum is conserved. Another thing is the total kinetic energy is also conserved. So using those two things, we find out the formula. Okay. So meanwhile, we get V1 minus V2 upon U2 minus U1 is equal to 1. That is coefficient of restitution. Okay. Coefficient of restitution is 1. Okay. So we get these two formulae for final velocities. Slightly difficult, I can say, to memorize, but we need to memorize them. Okay. So what is final formula? So V1 is equal to m1 minus m2 upon m1 plus m2 times u1 plus 2m2 divided by m1 plus m2 times u2. Okay. So what is the setup? Which is first body, which is second? The body which is ahead, it is the first body, and the body which is following, that is second body. Okay. So if you have like this, okay, this is first body, this is second one, then the formula is m1 minus m2 divided by m1 plus m2 multiplied by u1, okay, plus 2m2 upon m1 plus m2 multiplied by u2. So you have to remember this one, and this one will just follow. How will you get this formula? So I can say just replace m1 by m2 and m2 by m1 and u1 with u2 and u2 with u1. So you will get this formula. Okay. So that's a trick. In case you remember first one, don't remember second one, then this is how you will find out second one. Okay. So what is V2? So see, just replace M2 with M1, okay, and U2 with U1. 2 instead of M2, I will put M1. It is 2 M1 divided by M1 plus M2 multiplied by U1. Okay. Plus here I will have M2 minus M1. See, I have M2 minus M1 divided by M1 plus M2 times U1 will be changed to U2. Okay, so we get this formula. All right, is it clear? Yes, no? Okay, so the yes, yeah, you are audible. So we need to remember these formulae. Okay, at least for the case of elastic collision, right? At least for the case of elastic collision, we need to remember. After that, now we consider some special cases. So what will happen if u1 is equal to 0? That means first body is at rest and another body hits it with some velocity. So what will happen if u1 is 0? So this term will be 0 and this term will be 0. Okay, so if u1 is 0, this formula gets simplified. So v1 will be just equal to 2m2 upon m1 plus m2 multiplied by u2. Okay, and v2 will be equal to m2 minus m1 upon m1 plus m2 multiplied by u2. Okay, so v1 is 2m2 upon m1 plus m2 times u2, and v2 is m2 minus m1 divided by m1 plus m2 times u2. Okay, and on top of that, if you make m1 is equal to m2 is equal to m, then what will happen? First body was at rest, second body is following, and their masses are equal. So what will happen if it collides with the second body? Sorry, second body collides with first one, second one collides with first one will stop there, and second second one it will move. Okay, see, first one, suppose this is first body which is at rest, second one collides with it. What happens now? This one will come to rest. The body which is following, it will come to rest, and first one will begin to move with the same velocity as that of second one. This happens in case of the elastic collision. Okay, so there is exchange of velocities if the masses are equal. There is exchange of velocities if the masses are equal in case of perfectly elastic collision. This is an important point. There can be a question based upon this thing. Okay, so if m1 is equal to m2 is equal to m, there is exchange of velocities. This is an important point. I would say very important point. There can be direct questions based upon this thing. Okay, and there have been questions. Okay, so this is perfectly elastic collision. We can see some problems based upon perfectly elastic collision. Then we'll move on to inelastic collision. Okay, so let us see some problems. First one is the coefficient of restitution E for perfectly elastic collision is. Tell me. It's 1. Okay. Next question. A rubber ball is dropped from a height of 5 meter on a plane. On bouncing, it rises to 1.8 meter. The ball loses its velocity on bouncing by the factor of. So tell me. It is dropped from some height. It falls with some velocity. Let's call this h1, and it rebounds. It rebounds and goes to this height. Okay, it bounces and goes to this height. Let's call it h2. So with what factor does it lose its velocity? This is the question. Let's find out how much is final velocity. How much is, okay, how much is v2? It falls with velocity v1, rebounds with v2. Why? Because when it collides, there is some loss of energy because of friction, you can say friction with the ground. Okay, so can I say v2 upon v1 just equal to square root of 2gh2 upon 2gh1? Yes, so this gg will get cancelled, and you will have h2 upon h1 is 1.8 divided by h1 is 5. Okay, so that is, now we can multiply and divide by 5. Okay, because if we multiply and divide by 5, so denominator we can take out, right? This will be 5 times 5, and this is 1.8 times 5. So this thing will be 5 And how much is 1.8 times 5? 18 5s are 90. Okay, so this is also good. This will be 9. So square root of 9 is 3, and in denominator you have 5. So V2 upon V1 is 3 by 5. So this is ratio of final to initial velocity. What is loss in velocity? Loss in velocity will be V1 minus V2. Okay, and by what factor is the velocity lost? So it will be loss in velocity, delta V, you can say. So delta V divided by V, right? So that is V1 minus V2 divided by V1, and it is V1 upon V1 is 1, so 1 minus V2 upon V1. Okay, and V2 upon V1 is 3 by 5, so 1 minus 3 by 5 is 2 by 5. Option B. Is this clear? So you already said 1 minus V1 by V2 or something, you were saying 1 minus 3 by 5. How come? Directly. Or you did this thing in your mind? Okay. So you did this thing, or maybe you remember the formula. All right, remember the formula. Okay. Next question. A body A of mass 4m moving with speed u collides with another body B of mass 2m. The collision is head-on and elastic in nature. After the collision, the fraction of energy lost by the colliding body A is. Okay. Tell me. M1 U1 is equal to M1 V1 plus M2 V2. That is fine. Okay. After that, see, suppose this is body 1 and this is body 2. Okay. It's moving with speed u1. This one is moving with speed u2. What is our question? What is the change in velocity? Okay. What is the change in velocity of this first body? Not change in velocity. What is the energy lost by this first body? Okay. Right. This is the question. The colliding body, which is A, which I am calling as second body. So it will have some initial kinetic energy, K initial, okay, or let's call it Ki only, which will be half of m. What is mass of that body? 4m. So m2 multiplied by u2 square. Okay, and final kinetic energy will be half of m2 v2 square. What will be energy lost? Energy lost is just equal to k or delta k, that is ki minus kf. Okay, initial kinetic energy minus the final kinetic energy. So then you have half of m2 u2 square minus half of m2 v2 square. Okay, so you can take this thing common, half m2 common, or you can substitute the value of that. So it's half m2 u2 square minus v2 square. And what is v2? So here comes the formula. What is v2? So V2 is equal to what? 2 times M1 divided by M1 plus M2 times U2. Okay. So let me just check it once, because yeah, it's 2 times M1 upon M1 plus M2 times U1. No, first body, which one is at rest? Let us check. This one, first one is at rest, as we are considering it. This one is at rest and this one is following. Okay. The first one is at rest and second one is following. Okay. So U1 is equal to 0. This is equal to 0. And our total formula is 2 times M2 upon M1 plus M2 multiplied by U1, plus it is M2 minus M1 divided by M1 plus M2 multiplied with U2. So this thing is 0. Okay, this thing will be 0, and it is M2 minus M1 upon M1 plus M2 times U2. Okay, this thing is 0. So you have M2 minus M1. So that is 4M minus M1 is how much? 2M divided by M1 plus M2. What is M1 plus M2? 4M plus 2M, 6M multiplied by U2. So let's keep it as U2 only. This is equal to 2M upon 6M. Okay, so that is how much? It is 1 by 3. Okay, 2 by 6 is 1 by 3. So 1 by 3 U2, right? So you get this. Then you substitute that. So if you know the formula, you can directly find out this thing. Otherwise, you have to do, otherwise you will have to do, um, okay, you will have to find out the final velocity. So first you use this thing, the law of conservation of momentum. Okay, then you use law of conservation of energy, etc. Okay, so I don't want to go into that solution. If you want, you can see the regular lecture. I have explained that. Okay, but we want to do it fast, so that's why we'll use this method only. Okay, we'll remember the formula. All right, so what do we get? Half of M2 multiplied by, this is 1/3 of U2. So you have U2 square minus 1/3 of U2 square is 1 by 9 of U2 square. So how much will that be? This will be 1 minus 1 by 9 is 8 by 9. Okay, 8 by 9 of half of M2 U2 square. This is the answer. Okay, it loses by the factor of 8 by 9. Is this thing clear? Okay, actually it can be done faster, so don't think about this first. Just find out final velocity. Final velocity becomes 1/3. Okay, final velocity becomes 1/3. That means kinetic energy becomes what? It becomes 1 by 9. Why? Because it's directly proportional to velocity square. Okay, so forget this, find out this thing only. Final velocity becomes 1/3, kinetic energy becomes 1 by 9. If it becomes 1 by 9, that means with what factor the energy is lost? It becomes 1 by 9. That means 8 by 9 is lost. Okay, so don't go into this. This thing I have to do because I'm explaining it to you. Okay, but just find out the final velocity, then just find out final energy. Okay, so if final energy is 1 by 9, that means it is lost by the factor of 8 by 9. Right. All right. Let's move on to the next one. Okay, I can tell you 100 tricks, but you won't be able to do anything if you don't solve problems. Okay, so more important thing is, even more than, I would say, even more than the class itself, more important thing is practicing. So are you practicing? Okay. Next question. A moving block having mass m collides with another stationary block having mass 4m. The lighter block comes to rest after collision. When the initial velocity of lighter block is v, then the value of coefficient of restitution small e will be. Tell me. Moving block of mass m collides with another stationary block of mass 4m. The lighter block comes to rest after the collision. When the initial velocity of lighter block is v, then the value of coefficient of restitution is. This is simple. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, and you don't have to consider this one, okay, because this is 0, right? Then you can put the values. So you have m, moving block has mass m and its velocity is v, okay. So m times v is equal to m times v1 plus, it comes to rest, it is given, no, it comes to rest, so nothing. M times v1 is also 0, this is also 0, it is just m times v2, so m2 times v2, so 4m times v2. So from this we get v2 equals to, what, gets cancelled, v by 4, okay. So then e is equal to, what's e, v1 minus v2 divided by u1 minus u2, or vice versa, v2 minus v1, okay, divided by, uh, oh, what did I do? I'm sorry. Here the order is opposite, okay? It's v2 minus v1 divided by u1 minus u2, or you can say v1 minus v2 divided by u2 minus u1. Order is opposite of the numerator and denominator. All right, so we have v2, which is v by 4, v1 is 0, and what else is 0? u2 is 0, u2 is 0. So u1 is v. So this is just, okay, v by 4 minus 0 divided by v minus 0. Okay, so that's 1 by 4. That means 0.25. Okay. Next question. Two identical balls, A and B, having velocities of 0.5 meters per second and minus 3 meters per second respectively, collide elastically in one dimension. The velocities of B and A after the collision respectively will be. Tell me. This one you have to tell. And as I said, velocity gets exchanged. Okay. So they are asking B and A. So they have changed the order also. A and B changed to B and A. So it will remain same, 0.5 and minus 3. So answer is option B. Okay. Because if they had asked A and B, answer would be, I guess, answer would be option C. It gets exchanged. Okay. But they are saying B and A. So they have, okay, the question setter is playing smart here. He's changing the order. Okay, he wants you to make mistake, right? Because, okay, students, remember it like this, the velocity gets exchanged. So let's change the order. Okay. Anyways, so it's option B. And see how many times this question is repeated. Okay. The question will be repeated like this, or this fact is used that velocity is exchanged and something else is asked to find. Let's see next question. Two particles A and B move with constant velocities v1 bar and v2 bar. At initial moment, the position vectors are r1 bar and r2 bar respectively. Condition for particles A and B for their collision is, okay. So initial position vectors are given. Tell me what is the condition for collision? What should be final position vector? All right. So yeah, what will happen? Two bodies collide, their final position vectors will be equal, right? So final position vectors are equal. So I can say R1 at time t, R1 bar at time t is R2 bar at time t. Okay. So how can you find this final position vector? So you can find out displacement of bodies. Okay. Displacement of bodies. So I can say displacement of first body. Displacement of first body will be R1 at time t minus R1 at the beginning. Okay. And it will be equal to velocity multiplied by time. So it is velocity multiplied by time. Velocity is v1. Okay. And if I want r1 at time t, I will take this minus r1 on this side. So I get r1 at time t is equal to r1 bar plus v1 bar into t. And similarly, this thing will be r2 bar plus v2 bar into t. Okay. And then what you can do is, looking at the options, okay, then what you can do is you can move this v1 on the other side. You can move this v1 on other side and r2 on this side. What do you get? You get r1 bar minus r2 bar is equal to, okay, is equal to some time t multiplied by v2 bar minus v1 bar, v2 bar minus v1 bar into time t. Okay, v2 bar minus v1 bar into time t. And then which of the options is correct? Can you tell me if you know this? R1 bar minus R2 bar, it is something multiplied by V2 bar minus V1 bar. So these two vectors are parallel to each other. They are parallel to each other. So now see, first one, first one is not correct. Okay, or we cannot say about first one. Second one is they are okay. R1 bar minus R2 bar is equal to V1 bar minus V2 bar. So this is also not correct because you have this time in multiplication, and this it is v2 bar minus v1 bar, not v1 bar minus v2 bar. Is this thing correct? R1 minus r2 bar, okay, is equal to v2 bar minus v1 bar divided by their magnitude. Is this thing, can this thing be correct? It's correct, right? Why? Because if two vectors are parallel, then their unit vectors are equal. Yes, no? And what is this? These are unit vectors. Okay. If you want to find out unit vector for this one, r1 bar minus r2 bar cap, okay, then it will be this thing divided by its magnitude. Unit vector in this direction will be this vector divided by its magnitude, and in magnitude you will have time in numerator also, time in denominator also. The time will get cancelled. Okay, so I can say, I can comment here, if two vectors are parallel, parallel, their unit vectors are equal, and that's why the answer is option C. Is it clear? Okay. So we can just start from this that final positions will be equal because two bodies are colliding, and we can find out the answer. Okay. So can say this is medium kind of question, not very simple because some thinking is required in this question. Okay. Uh, it's not like you have formula and you put the answer. Some kind of thinking is required. Okay, mathematical thinking is required in this question. So this is medium to hard depending upon the student's preparation. Anyways, but if you know this thing, okay, I mean, if you figure out this thing, after that it is straightforward. All right, let's see next one. A ball is thrown vertically downwards from a height 20-meter with initial velocity v naught. Collides with ground, loses 50% of its energy in collision and rebounds to the same height. Initial velocity v naught is. So tell me what to do. Ball is thrown downwards from some height h, let's say, thrown downwards, okay, and it, it reaches here with some velocity v, suppose. It is thrown with velocity v naught, okay, and it loses 50% of its energy. Okay, it's given that it loses 50% of its energy here, and still it rebounds to the same height. Still it rebounds to the same height. Okay, so what does it mean if it rebounds to the same height? All right. So first of all, let's find out what will be its velocity when it falls. Okay. So when it falls, it, ball falls with velocity v. Okay. Ball hits ground with velocity v. So I can say v square equals to initial velocity square, v naught square plus 2gh. Okay. V square is u square plus 2gh. Then rebounds with, suppose, v2. Okay, it moves up, ball moves up with velocity v2 and reaches the same height. Okay, so ball rebounds with velocity v2, suppose. So now what will be relation between v2 and this height? V2 is equal to square root of 2gh, right? Yes, no? Yeah. And what is another thing given regarding v2? That the ball is losing 50% of its kinetic energy. Okay, ball is losing 50% of its kinetic energy. So I can say that half of uh, m into v2 square is half of m into v square. Okay, see, it is losing 50% of its kinetic energy. So kinetic energy becomes half. This is kinetic energy with which it collides. It strikes the ground. It's half mv square because v is the velocity with which it hits the ground. Okay, it rebounds with velocity v2. So kinetic energy is half m v2 square, and it is half of the kinetic energy with which it strikes the ground. Okay, then you can cancel out half m, half m. you get v2 square is equal to half of v square. Okay, you get v2 square equals to half of v square. So from here you get v2 square is 2gh, and it is equal to half of v square is equal to 2gh, right? Because v2 square is half of v square we just found. So then you have this equation 1. Okay, v square is v naught square plus 2gh, and here you have half of v square is 2gh. Okay, so here you can adjust this thing, or you can just substitute this thing, or I can multiply two sides with 2. So I will get v square is equal to 4gh. And what is v square? It is v naught square plus 2gh. So v naught square plus 2gh is equal to 4 times gh, and you can move this 2gh on other side. So v naught square is 2gh, and therefore v naught is equal to square root of 2gh. This is the answer. Okay, height is 20 meters. Put that height. So it is 2 times 10 times 20, 20 times 20. Okay, so answer would be 20 meters per second. Is it clear? Sure. Good, because we have done a few things in this question. Okay, all right, let's see next one. On a frictionless surface, a block of mass m moving at a speed v collides elastically with another block of same mass capital M, which is initially at rest. After collision, the first block moves at an angle theta to its initial direction and has speed of v by 3. Second block speed after the collision is, okay, you have two blocks and you have two blocks, mass m. Okay, so this one, let's draw balls only. So this is first ball collides with second one, which is initially at rest. Okay, this is at rest. After that, this one moves at an angle theta. First one moves at an angle theta. Okay, and what is given? Speed becomes v by 3, right? So what will happen to the second one? Second one will move at some angle, suppose. Second one, okay. What is asked? What is the speed of the second one? So how can we find? Tell me. What happens in elastic collision? Again, one more thing is conserved. Kinetic energy is conserved. So I can say half of m into v square, okay, is equal to half of m1, or it's m only, v1 square plus half of m multiplied by v2 square. Why am I choosing this formula? First of all, because I just want to find out speed, and I know what is the initial speed of the first body, initial speed of final speed of first body, it's given, okay, and masses are also known. So this is only one unknown, okay. If you use momentum, in case of momentum, you need directions. This is two-dimensional problem, okay. So if you choose momentum, it will be difficult. Okay, here it's easy. So m, actually half m gets cancelled. So you have v2 square equals to v square minus v1 square. and that is equal to v square minus v by 3 square, v square by 9. Okay, so v2 square is 8v square upon 9 plus, okay, it's 1 minus 1 by 9, 8 by 9 of v square, and therefore v2 equals to take square root 2 root 2 divided by 3 times v. This is the answer, right? Option C.